All right, so 4.3 exploration. So we have successfully downloaded data from the web in the previous video. So here, let's find some trends and patterns in the data so that we can um, use the code uh, in the prototype Shiny app in the next video. All right, so let's create a file. But yeah, so it starts with injuries data set here. But yeah, let's move to our studio. Um, so let's save this as 4.3 Explorer, right? And let's delete all this and 4.3. Um, so before we start exploring data, we need to import the data, right? So uh, import data. Um, and I don't know whether you guys noticed, but there's an outline. So that's sort of like table of content when you're doing R script file. So you can do this for consecutive dash lines here, then it shows up in outline, right? So there's import data, and what do we have? Uh, so I want to organize this first. So I mean, it's not a long section. So we're working on 4.3. So we create selected, and we focus on this product code 649. And 649 is toilets. So we're going to focus on injuries associated with toilets, right? And then number of rows. So number of injuries by toilets, there are 2,993 injuries or number of rows, right? And remember, the data that we're analyzing came from only 1 year, 2017. And the next section, we're counting injuries by location. And then we have weight. So this weight column in the data, um, so that is to scale this injury data to the entire US population. Okay. So injuries by location, body part, and then diagnosis. All right. And then, so, and then we are going to count the injuries by age and sex, and then save it under summary, and then we visualize. Okay. And there are two visualization. One is by count of injuries, and the other one is by rate of injuries after taking into account the population in each age group and sex. Okay. So, all right. I guess we can just go by without having subsections in this outline. So import, we're going to use uh, vroom function from the vroom package. All right. So we need injuries. So injuries and vroom, and hit tab, and there's injury. And then so um, let's print that, right? So you can print it like that. Control Enter. There you go. And then what else do we have? Population, vroom, vroom. It's a function that imports the data fast, right? You tab, population and population. Control Enter. Sorry, it's double colon. Control Enter. So we got population, and the last one is products. Products, vroom, vroom, and then products, right? Control Enter. All right, so we got all three data sets imported, right? And let's close this outline. And what are we doing? Yeah, so we create this selected object. So we're filtering for this toilets, injuries associated with toilets, right? So injuries data set looks like this, right? So we're looking at product code, yeah, and we're filtering for rows that have 649, which indicates toilets, right? 649. So here's one, row number 3. We're only filtering for those rows, right? So that is selected, right? So selected, um, so injuries by toilet, right? Oh, so could not find function, this pipe operator, because that is from the deployer package, and load packages. So let's load tidyverse package, control enter, right? And let's run this code again, right? 2,993 rows, right? That's what we have. And so we're going to count injuries by location, body part, and count, right? So, right. So here, count injuries. So selected, count location, and we want to sort this, control enter. Now, this is from the sample hospitals, right? The data that we're working with is came from a sample of hospitals in the country. What we are interested in, though, is the patterns and trends in the entire country, right? So this injuries data set also has this weight variable. So we can scale this injury data to the entire population, right? So the way to do this will be tab the weight, right? And then we provide weight column, right? Now, when we do that, see the difference? Now, 2142 injuries that occurred in whole, right? Now that is, 99,603. So, so that's when the sample data is scaled to the entire uh, U.S. population, right? So this is estimated number of toilet injuries that occurred at home, right, in 2017. All right. So we do the same thing in other variables, right? So the second, instead of location, what do we have? Body part, right? And then the third one is diagnosis, right? So control enter. We have uh, so injuries uh, counted by body part, right? So head injury is the most common one uh, amongst the toilet injuries, right? And diagnosis, other or not stated, contusion or abrasion, right? It's the most common after not stated diagnosis, all right? All right, so that is straightforward. And the next, we create this summary object, which is a count of injuries, toilet injuries by age and sex, and scale to the US population. And we're going to visualize that to, uh, to this chart, figure 4.1. All right, so let's do that. All right, so count by, what is it, age and sex, right? So we create, uh, we name it summary, and we count injuries. So injuries, we count what variable? Age and sex, right? And then we want to weight this to weight variable, and then we want to sort this, right? So that's what we have in summary. Oh, so yeah, we're not. I guess we're not scaling to the U.S. population, so we're just working with a sample here. Oh, I'm sorry. Yeah. So what we're not doing is sorting. So what we're not doing is sorting. So so we're providing this weight variable to the weight argument here. So yes, we're scaling to the U.S. population. We're just not sorting here. Okay, we're not sorting, right? So that is the summary object, right? And let's train it. Control Enter, right? So we should have the same um, result here. So age is 00, newborn, less than 1 year old, female male. So numbers are not the same. Did I miss a step in summary? Selected count age sex. Age sex. Um. Oh, I'm sorry. So instead of injuries is selected. All right. So again, we're just focusing on. So the difference between injuries and selected is selected focuses on toilet injuries, right? Control Enter. There you go. So 4.76 for female less than 1 year old. Yeah, 14.7, 14 point, 14, oh, 14.3, 4.76, 4.76. Correct. All right, let's move on. So now we visualize. So that's figure 4.1. So here, figure 4.1. So I think that is something that we can put on this outline. Okay, so it shows up here. So maybe we need indentation. So put one more hashtag. All right, looks good. All right, so summary, we're gonna plot this. ggplot, aesthetics, what's going to x? Axis, age. Y-axis, number of injuries, which is n. And then color, that would be sex. We have two lines, one for female, another one for male. And then that will be geom line. Control Enter. Yep, so that is the same. The only other thing is this label, right? So Control Enter. Now we have this y-axis label, right? So here again, as we discussed in the previous video, it goes up, right? It goes up, but then there's a steep decline after um, age 80, right? Very old people tend to have less injuries, toilet injuries, and that doesn't make sense because you would think that um, senior citizens are more prone to injuries, right? So that's where this figure 4.2 comes in. So this one, we take into account population. So if you look at the code here, we are joining population. So look how this selected data looks like, right? I mean, it's the same as injuries, but we just filter for this toilet, product code 649. If you look at population, it has age, sex, and population, right? So in other words, if we were to take into account population, in other words, we want to join these two, we need to, we need sex. So sex is there, male, female, the same values. We also need age. Uh, where is, oh, age is right here, right? So select it, count age and sex, and scale it to the US population. right? So, so let's do this, right? So that's basically the same as what we have done, right? It's the same thing we did. So this, right? Summary looks like this, right? Age, sex, and number of toilet injuries. Now we want to add or join this. So age, sex, we have two common variables, and then we're adding this population. We're adding this population, right? And that is that can be done using left join, right? And that's population. And I mean, the author used this age and sex, made it very specific. Join these two data set using these age and sex, but that's not really necessary. Are smart enough to know or see the common variables. So control enter. Now, if you run summary, you can see that we have n and population for age and sex. And in this operation, right, joining operation, it tells you, oh, this joining operation is done by this age and sex, right? Now, the next line is we're creating this rate, right? So divide the number of injuries by population, right? But then make it the number of injuries by 10,000 people, okay? So that is what we're doing. So here we're creating a new variable rate n divided by what's population, and then make it by 10,000 like that, or you can do scientific notation like that. Okay, so control enter. Oh, I'm sorry, mutate. Control enter. Now summary has rate variable that takes into account the population, and we can run the same code for visualization. Now instead of number of injuries, rate of injuries. Hold on. Oh, instead of n, it should be rate. Control enter. There you go. Right, and that is what we see here. Right. Okay, so this is the data visualization we want to put on our Shiny app. And in the next video, we are going to create the prototype in section 4.4. All right, great job, guys. I'll see you in the next video.